Hi, good morning. It's Jim from the Mavestar Observatory. Before we begin, I'm going to be answering a bit later on in this video the all-important big question. Do we face an extinction level event with regards to a pole shift? And if we do, what can we do about it? So stay tuned for that. So before we get into it, just want to say a big thank you to the people that are supporting this observatory, because you know why you're doing it, guys. You want the answers that these other organisations with relationship to these anomalies that we study here, mainly the pole shift news, the grand solar minimum, sea ice, extent, sunspots, etc. You know why we're doing the work that we do, and that is to get the answers to you guys. So, you know, if you want to support what we do, and we do a little bit more than talk, we're a bit more proactive than that. We actually build the equipment, put it out in the field, collect the data, process it and put it up on the website, and we try and get a forecast as to how long we've got with things like, you know, the magnetic pole reversing. So, you know, if you want to join in with the support, the links are down there. You can support us on Patreon or PayPal. It's entirely up to you, and of course it's not mandatory, guys, but you know, if we don't get support, we just can't simply build the equipment, put it out in the field and answer those questions. So it's important, really, more than anything, that we get a little bit of support. And let's face it, I'm quite good at, you know, achieving big results with little bits of money. You know, I mean, at the end of the day, we've got some of the sensors now that NASA, the ice cube down on Antarctica, and you know, the European agency use. So, you know, it just requires a little bit of skill, and I'm lucky to have that, to put these things together. And you know, we've got a great vehicle here on YouTube to, you know, contact people that are willing and like-minded like ourselves to, you know, take these on in their homes and provide the data, like Richard did from, you know, the Gold Coast in Australia the other day, and Tony does in Hong Kong, Jeff does in Perth in Australia, Brad, super supporter. Not only does he you know, fund some of this research as well, he also houses one of our stations in Kentucky, and we've got JD over there in California, who'll soon be sending us some data so we can catch up on those few months. So Jessie and her husband asked me a few times, and you know, I can only apologise for not getting back to you until now, the all-important question, and that is, you know, do we face extinction level event with regards to the magnetic pole reversal? And the reason why we're looking at this you know, chart here, it gives us an indication of how long ago the magnetic reversals have happened and how frequent they have. So I just want to say, first of all, you know, we have had, as you can see, many magnetic completed reversals. The excursions aren't marked on this chart, just the completed reversals, but what you will see is the last one at the top of the chart being the very longest period of time out of all of those. There is a white one just 4 segments down, which is nearly as long but not quite. So we are in the longest period of time that the Earth has taken for a magnetic reversal to complete. And you know, my question is, and of course Jess's is the same, you know, do we face an extinction level event as a result of this coming pole reversal? Because the last 3 have happened every 300,000 years or so. If it's out of 100%, I think it's 80% unlikely we're going to face an extinction level event with regards to this, and I'll just explain to you why there is that 20% uncertainty in that element. So first of all, if we take a look at just our neighbouring planet, Mars, it used to have a magnetic pole, and I dare say it probably went through reversals. We won't know until we do more studies on the terraform of Mars, but what we do know is that it did have water, and it did have an atmosphere, and it certainly at one point in its history had a magnetosphere. So there must have been something at work within its core, similar to our Earth's, that generates the magneto, in turn generates the magnetosphere and gives us our magnetic poles. But Mars has lost its magnetic poles, and as a result of that, its magnetosphere would have collapsed, and as a result of that, it would have left Mars's atmosphere subject to a term now which NASA are doing a lot of study on, called sputtering. It's when the the atmosphere erodes away with solar radiation hitting it and stripping it away, as well as other cosmic radiation. And once an atmosphere is gone, then the water on the planet is exposed in a very similar way, and it is only a matter of time before that water goes. So if we look at the terraform on Mars, we can see the rivers that would have took thousands of years to erode those riverbeds that look like little veins across the surface, and we can compare that with the fact that it lost its magnetosphere at some point, and very likely as a result ended up looking the way it does now. If there had been life on Mars at the point in time where it had water on its surface and an atmosphere, then as a result of losing that magnetosphere, it would have lost the complete range of biodiversity on the planet. And that would be no too dissimilar to what would happen if our Earth lost its magnetosphere. And what Mars is a big reminder of is that it can happen, guys. And it's happened to our closest, nearest planet, Mars. So with that in mind, and with the fact that our Earth has taken its longest period of time to go through a completed magnetic reversal, I therefore put that 20% uncertainty in there. But I will say this: if we do lose the magnetosphere of the Earth permanently, then it will only be a matter of time before all the biodiversity on the planet is completely sterilised and no longer here. What could we do if we lost our magnetosphere? I think as an emergency response, the first thing we could do is probably go underground in big cities, but they would only be able to support small numbers of people. Now, we do know that there have been big cities built, but we don't know if the purpose of those cities that have been built at the moment are for a potential disaster related to the magnetic poles or something else. But what I will say this, guys, is if we lose our magnetosphere, the majority of the biodiversity on this planet will die in the same manner as it very likely did on Mars. So that's why I say 20% is possible, but it's most unlikely, and that's why we say 80% chances that won't be the case. But that doesn't mean with what's taking place on our planet isn't severe enough. So if we just then put that aside, okay, so let's just say, okay, our planet has stalled, and there's no more magnetosphere, and therefore the biodiversity is gone. If we take that scenario and put it to the side and just look at what scenario we are dealing with, it's very severe. We depend on a majority of this land that we've got on our Earth now for crop production, and we have changed a lot of things in recent years. And in the last 30 years, we've seen some dramatic changes as a result of just the pole migrating, nearly 40 degrees across the northern hemisphere. We've seen the Atlantic anomaly increase in size. It's now spreading over towards South Africa, and that means that there is a big hole in our protective field, and it is likely, and we're going to answer that question very shortly, how much radiation is inbound in that region when we put one of our muon detectors in there. And we're also going to put one in one of the high intensity regions, which is still left on this planet, covering just the south coast of Australia, somewhere central. And with that information, when we get it back, we will know what to expect as a result of low protection and high protection with these high intensity and low intensity regions. And that really is what we want to ask. That we want to ask the question, what are the risks in these low and high intensities, and we want to ask the question, what can we do if we find ourselves in an emerging low intensity region? And the only way we're going to do that is by putting the equipment out there, guys. But with the shrinking of the agricultural land on this planet and 7 billion souls on it, it poses a very serious effect, a very serious and realistic possibility of, the world we live in right now collapsing as a result of that. We're already starting to see some crops go offline in countries, and they're having to import those crops that they used to grow themselves. And all I want to say, guys, is that if we just go back into the history of our planet, there has always been change with regards to climate. And it may not have been related to magnetic pole reversals, or it may well have. I mean, we had an excursion event, a magnetic excursion event, around 12,000 years ago, and at around about the same time we came out of a glacial period. Now we're on the cusp of going back into a glacial period, and the Earth could put us back in one of those, and the magnetic poles of this planet could be responsible, as well as the hindrance right now that we're getting from the low consecutive 3 solar cycles of low output of sunspots, called the grand solar minimum. All this spells calling for the planet. And what is going to happen is this agricultural land is going to go offline. But if we look at around the medieval period, we see that migratory Vikings were living on that Greenland continent at the time, because at the point in time where there was settling on there, they could grow crops and sustain themselves on there. But it went colder again on Greenland, and they vanished from them settlements and had to migrate elsewhere. We got a big problem because we got borders and we've got governments all around the world, and they don't particularly want fleeing refugees from certain parts of the world all landing on their shores, because there is a possibility that they will get fed. When I said in a few videos ago that in the next 10 years we could see at least 1 billion people die as a result of what is taking place on our planet, it is very realistic projection. We're losing our cropping land, and we're increasing the numbers of humans on the planet at the same time, and we have not even reached the equilibrium point of this anomaly, with the magnetic pole reversing. We've not even reached yet the equilibrium of the grand solar minimum and the last 3 solar cycles, showing a trend where things are going to get better. And the only way we will know that is in the centre of solar cycle 25, to know how big that solar cycle was over that period of time. So we can only go on the trend that we see at the moment, where the solar cycle has depleted year in year out, to know how that is going to play out. And I would always edge my bets on the last 3 cycles that we've saw. So I don't believe solar cycle is going to be a very strong cycle. That's if it even gets off to start with. I mean, we've had now a period of time go by where there hasn't been any sunspots at all. And I know a lot of other scientists will say, well, Gene, you have to wait, because we are, after all, in the trough, or at the bottom, or at a solar minimum, and sunspots at those periods of times are very few and far between. Well, I do give them that, but looking at the past 3 solar cycles, we can see that this is exponentially dipping off the chart. And for that reason, I'll go with the trend. With regards to the magnetic pole shift, we've been looking at the Canadian high intensity shrink off in the last 7 years to around 50% of its potency, and I predict when we do see that dissipate completely, we will be in the midst of our pole shift. Whether that is a sudden event or a prolonged event is yet to be efforted, guys. We don't know all the answers, and the only way we can find out the behaviour of the beast is by studying it, unfortunately. And that's what we're trying to do our best on here. As it is the primary objective to observe here at the Mavestar Observatory. So I've hopefully answered a couple of questions for you guys. It's not just about I just want to add this, it's not just about the food diminishing, food prices going up, because what will happen is there is going to be several other knock-on effects with regards to this. What you have to remember is that the only thing that has sustained reasonable sized cities in our ancestral history has been food production. Whenever the food has not been plentiful, the cities have been abandoned, and that will be the same scenario for us in this modern world. The only other thing is that we have a lot of technology that depends on people working that technology excuse me, and when they don't want to go to work because the amount of money that they earn in that job no longer sustains the amount of food and the rent to put on their roofs, they won't want to go to work. and a lot of people will begin to lose their properties as a result of that. A lot of people are, as we've started to see in the UK here, go out to the farms, and we've already started seeing this, stealing cattle, slaughtering cattle on the farmlands because it's just getting too dear to buy meat, and they're not going to give up the meat, but they don't mind the risk of going out there, stealing it, slaughtering it on the farmer's field. But all that's going to do is have a knock-on effect when farmers provide food for retailers that provide food for hundreds of people. But if farms haven't got the food to send into the shops, it's only going to escalate the problem. So we face a lot of knock-on effects as a result of this. If people don't start turning up for the jobs because the salaries no longer pay for a reasonable lifestyle, they might migrate out of that country at alarming rates. And as a result of that, you might not have the people that can work the infrastructure in there. And as a result of that, the grid could go down. There's a lot of scenarios that are very likely to happen as a result of just what has took place already. Our jet streams, as you guys know, are no longer conforming to the way there was 30 years ago. We've got polar jet streams mixing with subtropical jet streams over northern and southern hemispheres. And as a result of that, we are getting flash floods, droughts, in and around the world, as you guys already know. And this is going to continue because we've not reached the equilibrium point, or the center point at where things start to get better. Remember, we've not seen anything get better with regards to these weather anomalies that have took place over this period of time. So that's why I say things don't need to be an extinction level event for them to be severe enough, because trust me guys, things are severe enough. And we haven't even talked about cosmic radiation yet. And just briefly, I'll go over that. As a result of the grand solar minimum and this magnetic pole shift, and we've not got into the complete collapse of the magnetosphere. But when that happens, it will drop to about 90% of its strength. Sorry, about 10% of its overall strength of 100%. And when that happens, we will have an inundation of cosmic radiation. Guys, we've already got 3 to 4 times more cosmic radiation inbound in our atmosphere than what we had 30 years ago. And records prove that. So as a result, our risks with regards to just cosmic radiation has increased 4-fold. And as you guys know, it can cause cancers. So you're 4 times more likely now to get cancer as a result of cosmic radiation, probably muons. You're 4 times more likely to be affected by your cardiac arrhythmias than you was 30 years ago. And this is only going to get worse as the magnetosphere depletes and the grand solar minimum continues not to reach equilibrium. We do face some real severe risks. And of course, there is, like I say, many other scenarios that we can throw into this. If we've got a weakened magnetosphere and we get a large or even moderate solar flare off the planet, it'll knock the grid down. So it affects our infrastructure for a lot of different reasons, and all these are very possible scenarios that can happen. And that's why we took it upon ourselves to make that effort here at this observatory, get this equipment out and find out as much as we possibly can to answer the questions, because Swarm mission now has been going for a few years, and they've capped the information at level 2, so we can't really get the data that we're interested in. So we've had to take it upon ourselves to put magnetometers around this world to find out what the game is with these high intensities and low intensities. And we've took it upon ourselves to build the TriMag to track the magnetic North Pole. And we've gone now to the next level of building these muon detectors to find out how much radiation is inbound with regards to muons in these regions. So we're doing absolutely everything we can, guys, but the only thing we could do with a little bit more from you guys is a little bit of support and backing. So I'm going to leave it here, guys. I hope I've covered this question good enough for you, and I hope I haven't depressed you guys too much with the real risks that we do face in the coming short period of time. So with that, I'll say what I usually do. You have an amazing time. Links are down there if you want to support us, and as always, bye for now.